Hinsberg test is used to distinguish primary, secondary, and tertiary amines. This reaction includes two steps, where the first step is the mixture between amines and benzene sulfonic chloride in the presence of potassium hydroxide, and then the mixture is acidified by hydrochloric acid. The observation that we will obtain for both primary aliphatic and primary aromatics amines are the same. Okay, so for the first step, our amines will reacted with benzene sulfonic chloride in the presence of excess potassium hydroxide. Okay, so first kita akan ambil the hydrogen, one of the hydrogen from our amines. Okay, so combine it with chlorine on the benzene sulfonic chloride. So kita keluarkan the HNCl and then combine these two structure together, we will get a water soluble salt. Okay, so here on the nitrogen, since we have another hydrogen, okay, so the bonding between the nitrogen and hydrogen, okay, we have two electrons here, will goes to the nitrogen. So nitrogen will have two lone pairs and with one negative charge on the nitrogen. Okay, so since we have a potassium hydroxide here, so potassium K plus will make an ionic bond with the nitrogen minus charge. Okay, so the observation here, we will have a clear solution. Okay, and then for the second step, when we reacted it with hydrochloric acid, okay, since dekat nitrogen ni we have so many electrons, kita ada dua lone pair, so one of the lone pair in the nitrogen can be donated to the H plus from the acid. Okay, so bila nitrogen attach buat bonding balik dengan hydrogen dekat sini, so we will get a water insoluble, which is a white precipitate form. Okay, same goes to primary aromatics amine. So first kita keluarkan H dengan Cl, H from the amines and Cl from the benzene sulfonic chloride, and then one of another hydrogen on the nitrogen here, dia akan bagi both electron on the nitrogen, and then we will get two lone pairs on nitrogen with negative charge, and then the K plus will make an ionic bond with the negative charge of nitrogen. This is a water soluble salt, a clear solution form. Alright, and then when we reacted with acid, okay, one of the lone pair or nitrogen will be donated to the H plus of the acid. Okay, so bila dia dah buat ikatan dengan H plus ni tadi, we will have a water insoluble, which is a white precipitate form. So sama je dia punya observation. For the secondary amines, okay, tak kisahlah aliphatic or aromatic. Okay, since on the nitrogen, on the secondary amines only have one hydrogen attached to it. Okay, dia ada satu saja hydrogen. So this hydrogen will be combined with the chlorine from the benzene sulfonic chloride. So ni pun sama, dia combine together, and then we combine these two structure. Okay, kita combinekan tanpa H dengan Cl. Okay, we will get a water insoluble salt. Okay, so this one for the first step, white precipitate form. Okay, so sama je primary secondary aliphatic ataupun secondary aromatic. Okay, for the first step, okay, reaction of secondary amines with benzene sulfonic chloride in excess potassium hydroxide will form a white precipitate. Okay, kita akan nampak white precipitate on the first step. Okay, for the second step, reacted with HCl. Okay, so since dekat sini, walaupun on the nitrogen we got one lone pair, okay, walaupun kita ada one lone pair, since dekat sini we have a large electron withdrawing group. So the nitrogen here, the electron on the nitrogen here, so dia akan tertarik kepada electron withdrawing group. So it makes that the nitrogen could not donate the lone pair to the H plus. So dia tak boleh donate the lone pair to the H plus. So no observable change. Okay, tak ada reaction dekat second step for the secondary amines. So the white precipitate that we obtain from the first step will be remain. Okay, kita akan nampak, masih akan nampak white precipitate daripada first step ni tadi. Okay, tapi untuk second step, no reaction. For the tertiary aliphatic amines, okay, untuk tertiary aliphatic amines ataupun tertiary aromatic amines, okay, since there is no hydrogen bonded to the nitrogen, okay, so bila reaction dengan benzene sulfonic chloride in excess potassium hydroxide ni, for the first step, tak ada reaction. Okay, so no observable change. So clear solution je yang kita akan nampak from the two solution here. Okay, so and then for the second step, when we add hydrochloric acid, alright, so since here, okay, this is a tertiary amines, dia ada lone pair pada nitrogen, so the lone pair can be donated to the H plus. So dia akan buat reaction, a water soluble salt will form. Okay, still clear solution. Same goes to tertiary aromatics amine. So, as a summary, okay, for the primary amines, tak kisahlah aliphatic or aromatic. Okay, for the first step, the addition of potassium hydroxide with the benzene sulfonyl chloride. Okay, so we will get a clear solution. And then for the second step, we add the hydrochloric acid, white precipitate form. For the secondary amines, okay, so both step, okay, kita akan nampak white precipitate. Okay, so sebenarnya the white precipitate will obtain in the first step bila kita reaction dengan benzene sulfonyl chloride with potassium hydroxide. Okay, so the next step here, the second step sebenarnya tak ada reaction, but then the white precipitate remain. Okay, for the tertiary amines, okay, dua-dua kita akan nampak clear solution. So that's how we distinguish the primary, secondary and tertiary amines by using Hinsberg test. So tak bolehlah buat satu step je, kena buat dua-dua step because daripada both step kita nampak dia punya perbezaan. Okay. Next, we have a nitrous acid test. Okay, kita ada nitrous acid test where we are going to use a nitrous acid. Okay, so this nitrous acid is a very weak acid and it is unstable. So usually we are going to prepare it in situ. So kita akan buat waktu tu juga. Nak guna the solution, waktu tu baru kita prepare. Okay, so the preparation of the nitrous acid is from the reaction of acid. Okay, kalau guna HCl. Okay, and then we have a sodium nitrite. Okay, NaNO2, then we will get our nitrous acid. So kalau pakai sulfuric acid pun sama, react dengan sodium nitrite, kita akan dapat nitrous acid. The nitrous acid test can be used to distinguish primary aliphatic amine from primary aromatic amine. So kita akan nampak difference observation for these two amines. Okay, so since the nitrous acid is prepared in situ, so kita tak boleh terus tulis reaction of our amines with HNO2, tak boleh. So kita kena tulis NaNO2 plus HCl because the reaction of NaNO2 and HCl dekat sini baru kita akan produce our nitrous acid. And then the condition required is 0 to 5 degrees Celsius. So for this reaction, okay, I'll suggest you to draw the HO and double bond O. Draw lah kat mana-mana. Okay, so tujuan kita draw this one, the hono here. Okay, so kita tahu macam mana kita nak buat the reaction. Okay, so the first step, kita akan keluarkan air. Okay, we are going to remove water. Since on the nitrogen here, okay, pada nitrogen ni kita ada dua hydrogen. So we have two hydrogen here. Okay, nak remove water, okay, kita perlukan lagi satu oxygen. So instead of this one ada O dengan H. So kita tak ambil this one. So kita akan keluarkan water from this oxygen. So kita akan dapat this one. Okay, the nitrogen dia akan bonded dengan another nitrogen here. Okay, so dekat sini dia akan buat double bond. Okay, and then OH ni dia akan keluar. So dia akan right, so OH ni dia akan keluar, dia akan ambil kedua-dua elektron ni. Okay, so dia keluar. So dekat sini the lone pair on the nitrogen dia akan buat triple bond dengan this other nitrogen. Okay, so dekat sini ada double bond, and then bila dia bonded together with this nitrogen, okay, so the lone pair dia akan bagi jadi triple bond. So this is an aliphatic diazonium salt. Okay, it is highly unstable. So kita tak akan dapat ni. Okay, sebenarnya kita tak akan dapat this product di mana this one, okay, dia akan break the bond between the carbon and nitrogen. So nitrogen akan ambil kedua-dua elektron. It will produce a nitrogen gas. So the observation that we'll obtain for this reaction for aliphatic amines, okay, primary aliphatic amines is bubble gas evolve. So kita akan nampak nitrogen gas evolve dalam solution. Alright, and then bila ikatan antara carbon and nitrogen is break, okay, bila dia break the bonding between the carbon and nitrogen, here we will get a carbocation. So dalam case ni primary lah because only got one alkyl group attached to the positively charged carbon. So primary carbocation. Okay, so this carbocation, okay, dia akan react dengan water to produce an alkene. Okay, dia akan menghasilkan alkene, and then we have a Cl minus here. It will produce an alkyl halide, and also the OH minus here will produce an alcohol. So dia akan ada tiga mixture of organic compounds. Ada alkenes, ada alkyl halide, ada alcohol. But then for the primary aromatics amine, okay, so sama juga. Alright, so here we are going to draw the HONO. Okay, kita keluarkan HO and double bond O. Okay, so sama juga. Since we have two hydrogen on the nitrogen, okay, so kita nak remove air, kita akan buat ikatan dengan O dekat sini. So, and then combine the nitrogen and this nitrogen. Okay, so the lone pair on this nitrogen, dia akan jadikan triple bond. Alright, so we will have a benzene diazonium salt. So, benzene diazonium salt is stable if it kept below 5 degrees Celsius. Okay, pada suhu below 5 degrees Celsius, the benzene diazonium salt dia lebih stable berbanding aliphatic diazonium salt. Okay, so in this reaction, okay, kita akan obtain a clear solution. Okay, so pada suhu 0 to 5 degrees Celsius, we will see a clear solution form. So dia tak ada bubble gas langsung. Okay, but then if you heated the solution, okay, ataupun you tinggalkan pada room temperature, so means that the temperature here is bigger than 5 degrees Celsius, a nitrogen gas will be evolved. Baru kita nampak bubble gas evolve. So kalau kita nak bezakan antara primary aliphatic amines and primary aromatic amines by using nitrous acid test, we have to keep our solution between 0 to 5 degrees Celsius. Baru nampak dua observation yang berbeza. For the secondary aliphatic and secondary aromatics amine, okay, so kita tak boleh gunakan to differentiate the secondary aliphatic amines and secondary aromatic amines because the observation obtained for these two compound is the same. Okay, we get a yellowish oil. Okay, dua-dua akan dapat yellowish oil. So for the reaction, okay, so same like before, kita keluarkan HONO, HO, single bond and double bond O. Okay, keluarkan HONO. Since on the nitrogen only has one hydrogen, so kita nak remove water, kita akan ambil the OH here. Kita ambil OH, kita ambil H, okay, kita keluarkan and then terus sambungkan the structure. So the nitrogen here will make a bonding with N double bond O. So this is a N-nitroso-dimethylamine. Okay, so kita ada N-nitroso-amine di mana nitroso N double bond O ni adalah nitroso. Okay, this one is a nitroso is attached to the nitrogen. So N-nitroso. So bila nitroso attached to the nitrogen, we will obtain a yellowish oil. Okay, kita akan dapat yellowish oil. Okay, so sama juga for the secondary aromatics amine. So we have one hydrogen on the nitrogen. Okay, so kita keluarkan HONO, HO, single bond and double bond O. So since kita nak remove water, okay, so kita dah ada satu hydrogen, so we need the OH here. Okay, baru dapat air and then kita just rapatkan the structure. So nitroso attached to the nitrogen, so that's why we will get yellowish oil. Tertiary aliphatic amine and tertiary aromatics amine can be differentiated by using a nitrous acid. Okay, so for the tertiary aliphatic amines, alright, so same like before, kita keluarkan HONO, right, HO and double bond O. Alright, so since there is no hydrogen attached to the nitrogen, so kita tak boleh nak remove water dekat sini lah. So what would happen since we have a HCl, kita ada HCl dekat sini, so amines ni bersifat basic. Okay, dia adalah base. Okay, dia adalah base. So kita ada acid. So the nitrogen here, okay, ada lone pair, dia akan donate one of its lone pair. So dia akan donate dia punya lone pair ni pada H+. So that's why here we will have an alkyl ammonium. Okay, alkyl ammonium ion. Okay, so since here we have the Cl minus, so N plus. Okay, bila nitrogen dia donate kepada H plus, so dia akan menghasilkan N positif dekat sini. So we have the Cl minus. Okay, alkyl ammonium chloride. Alright, and also, okay, another compound that will be formed adalah the N plus ni dia akan attach pada N double bond O. So N-nitroso ammonium. So dia bukan N-nitroso amine tetapi N-nitroso ammonium sebab dekat nitrogen ni ada positive charge. So the observation that we will obtain from this reaction is a clear solution form. But for the tertiary aromatics amine, so sama juga kita ada HO, single bond, and double bond O, kita keluarkan HONO. Alright, so since on the nitrogen, dia tak ada pun hydrogen, okay, dia tak ada hydrogen, but then, okay, the hydrogen from the para position, okay, pada benzene ni kita ada hydrogen pada para position, so this hydrogen, dia akan buat ikatan dengan HO to remove the water, so the nitroso and double bond O ni dia akan attach pada para position. So this one is para nitroso aniline lah. Okay, para nitroso aniline. So the observation that we will get is a green precipitate form. Okay, so bila nitroso compound attach pada para position of the benzene, we will obtain a green precipitate. So, as a summary, for nitrous acid test, okay, kita dividekan kepada aliphatic and aromatic. For the primary aliphatic, a bubble gas evolve, kita akan dapat nitrogen gas. And for the aromatic, okay, below 5 degrees Celsius, we will obtain a clear solution. But then, if we leave it at room temperature ataupun apabila kita biarkan temperature dia tinggi, lebih daripada 5 degrees Celsius, a bubble gas evolve. Alright, for the secondary amines, okay, untuk both aliphatic and aromatic, okay, the observation are the same, yellowish oil form. But for the tertiary amines, okay, for the aliphatic tertiary, okay, clear solution form, but for aromatic, green precipitate form. Next, we have an identification test of aniline by using bromine in water. Okay, so when aniline is treated with bromine in water, okay, the bromine will enter the position of O2 and para in the benzene. Okay, dia akan masuk pada carbon nombor 2, 4 dan 6. So, we will get a white precipitate. Okay, kalau ingat balik, sama macam phenol. So, aniline dengan phenol, kita tak boleh gunakan bromine test in water to differentiate these two. Okay, because both will produce a white precipitate. Okay, the observation obtained is reddish brown color of bromine decolorized and white precipitate form. Last but not least, let's have a look at the coupling reaction of diazonium salt. So the diazonium salt, okay, benzene diazonium salt, when treated with this group, okay, kita ada dekat sini katakan the G here is the tertiary amino groups or the OH group. Alright, so this reaction is a coupling reaction where it will form an azo compound. So azo compound ni biasanya kita gunakan sebagai dye. Okay, dia boleh gunakan sebagai dye sebab dia akan menghasilkan a high intensity of color. So let's have a look at the first example. So let's say if we have a benzene diazonium chloride, okay, treated with phenol. Okay, kita buat reaction dengan phenol. Okay, the triple bond from the nitrogen here, okay, one of the bonding will goes to the nitrogen, right? So this nitrogen will have two lone pairs. Okay, so one of the lone pairs, okay, dia akan ambil the hydrogen from the para position of our phenol. Okay, so this one ada satu hydrogen, one of the lone pair will make a bonding. Okay, so dia akan keluarkan the hydrogen from the para position and then just combine these two structure. Okay, so N triple bond N ni tadi jadi N double bond N. Okay, and then this nitrogen terus buat ikatan pada carbon on the para position of phenol. So from this coupling reaction, okay, the observation that we will obtain is an orange precipitate form. Okay, so a high intensity color of orange akan terhasil. When the benzene diazonium salt is treated with a N-dimethyl aniline, okay, so kita ada tertiary aromatics amine here. So same like previous reaction, okay, so the triple bond in the nitrogen here, okay, one of the bonding, okay, will give the lone pairs to the nitrogen, okay, and then the lone pairs, okay, will take the hydrogen from the para position of our amines, okay, and then just combine the two structure, we will have an azo dye which is a butter yellow form. Last but not least, if we reacted our benzene diazonium salt with para dihydroxybenzene, so now the OH is on the first and fourth carbon of benzene. Okay, so this two carbon and these two carbon, since it is symmetrical, so our N double bond N, okay, so dia tak kisah nak masuk dekat mana, nak masuk sini ke, sini ke, sini ke, sini ke, sama saja because it is symmetrical. So let's say I'll put it here, okay, so sama juga dekat sini sebenarnya, the N triple bond will become N double bond, okay, N double bond N, alright, and then the hydrogen from this carbon, okay, kalau saya ambil this hydrogen, okay, the H plus and Cl minus, dia akan keluar, alright, and then we are going to combine our N double bond N with this carbon lah, okay, so kalau kita ambil from this hydrogen pun sama je, sama dengan this one and this one, sebab semuanya adalah symmetrical to each other.